Welcome to another episode and video on my riding robot discovery based on the TXT controller from Fischertechnik. Last time I actually checked on all sensors and the lamp. Does it work well? Does it work well? Is it doing everything that is possible? And I also checked with the oscilloscope on the pulse width. And actually right now I am trying to do the same, but in a little different manner, because all too often it diverges from its straight line. And right now with Acupax centered around the middle line, with the robot exactly on the middle line, I want to see how it behaves. Also, you may have noticed the last episode that the camera is missing. I'm not doing anything with the images right now, so much for the camera. I've taken it off. It has no use for now. Actually it's the camera that I'm using for making the oscilloscope images you will see later on, and you may have seen last time. The controller is off now, so I'm going to boot it and see if it boots, and if so, how well it goes. It's a freshly charged battery, Acupax. Community edition is booting. So far so good. No gray display. Let's wait and see. Yes, that is a display. Not the latest community firmware, by the way. I will try to settle that in the very nearby future. This also means that I have to log in into the controller. There we go. Let's do the other one as well. Alright, I am in. So now next step is to actually run the software and see how it behaves. And equally important, does it stay powered on? And it diverts. It absolutely diverts. And to be honest, I was hoping it would divert. So let's lift it and put it back on its place, see it if it diverts again. Because as long as it diverts, I can maybe check with the oscilloscope what happens. Well, this is the whole shebang, except that it diverted again, be it not as much. But it did sound, it did the light, sonar and touch sensor. So everything went well except for the diversion. And with that I actually want to see for the oscilloscope how that works. Only problem is how does it do on the scale that I can do with the oscilloscope, because that's not such a range as this one. That's a good one. I'm going to test it on a much shorter distance. So how am I going to do this? First of all, put it on the middle line halfway and put these, say, like this. Much shorter distance, and I hope this will work and work out. So let's see. It is still powered on. Alright, so that's a diversion in the other direction. So the last two attempts it went like this way, and now it went like this way. And also you may have noticed that the lamp went on, but it didn't turn. So for now I don't mind about that, not that much anyway. But it shows that even on a very short distance the diversion can occur. So let's test that again. And this will be alright on the middle line. Alright, kind of equal distance. The battery is done on equal distance from the middle line. Okay, close observance. It drives, diverts in that direction, collides and turns. So everything happens, including a diversion. That is actually good measurable, I hope, with your oscilloscope. Let's do another test. And by the way, the whole thing is of course that it shouldn't divert, it should not divert at all. But the fact that it does happen, even on such a short distance, is it indeed due to the current commuter firmware? Alright, now I'm wondering, contact 1. Yeah, okay, contact 1, and then it indeed has to turn that way. So with these first results, I think I should relocate to to the computer with the oscilloscope. I think that's a very good idea. And test further, doing the same, but with measuring. So let's do so. Alright, relocated, and as you can see, the display is off. Unfortunately, during the transport it stayed on. It's battery powered now, since the beginning of this test, and for some reason it powered off. So let's see whatever happens this time. So far it looks nice. And it is there. We're back in business. That means that I can hopefully successfully log in again. Yes, I can. And by the way, this is a camera which I'll have to shoot a little bit. From the sunlight, that's better. Anyway, let's log in here as well. FTC stands for fischertechnik Communion. I did not make that up. That is done by the people who developed the fischertechnik Unity firmware, which has nothing to do with the IP address I'm using, but that's an entirely different story. And if you have watched my previous videos on this subject, you might know why. Anyway, ready to roll and see if the behavior is the same as with the floor test, because now I am on a rather maybe very slippery desktop. But let's see anyway. And that's actually a very nice thing. And I didn't even see if it diverted. So right now it's all powered on, and I'm going to connect an oscilloscope probe, which I want to do to the motors, because the motors are the ones who cause are the cause of the diversion. So this is the yellow line, and now hopefully I can successfully connect to the blue one as well. But I think this is not going to work. I have to put it like, and there goes my controller. I have to power up. That gives me the opportunity to actually connect the wires. This is the way I would like them to be. First, let me power them up again. and let's see how that works out. And actually this does not work out quite as nice, because this time it ended up with a grey screen. So let's see if I can successfully power it down and up. See whatever happens now. It takes a bit of time. But you know that by now. And we're back in business. That also means that I have to log in again. Alright, here I am. Of course, here goes the same. That also means that the other computer where I still was logged in, I have been thrown out as well. But that's a different thing, for now at least. Alright, now I can do exactly the same thing. Run it, but now I can also watch the signals here. And I do hope see, that's the whole point. Here for the oscilloscope I want pulse, because it is pulse width modulated, or should be anyway, as far as I know. I'm keeping it to 5 milliseconds. That's fine as far as I'm concerned. And it's set to one block is 5, so they should be somewhere here, and they should be somewhere here if everything is alright. We'll see. We'll just see. Let's go. Oops. Let's go. This is signals, and there is some diversion, but is it what I want to see? So let's put it back in place. And do it again. And now I have two things to watch. Does it run in a straight line? And what's happening here? Well, either way I will look here. The other thing is, of course, in what timeline do I watch it? Very condensed. Well, let's keep it this way. This went on, and that's motor 1. Motor 1 went on for a longer time. And I thought I saw it going straight. Hard to watch. Hard to see what's happening. But let's try it anyway. I knew something was not entirely set up correctly, and I realized the time setting was not entirely correct. It was set to 5 microseconds, and or 500 microseconds, doesn't matter. And anyway, it was microsecond scale, and I am dealing with some millisecond scale. So I've set it now to 500 milliseconds, assuming that that indeed is the case for the pulse width, assuming it is pulse width, but so far everything has been. So let's check this out. Will this work or won't it? Hopefully in a straight line. Or maybe not. That's a clear diversion and a very clear signal. That was a very clear signal. And actually too short. So I'm extending the range once again. But it did divert. So let's do it again. And actually the blocks are just right here now. No diversion. And they all indeed looked exactly the same. These blocks looked exactly the same. But it's also shown that this is now the right time base. So that in itself is very good. And now this is set up correctly. You will always see that it doesn't divert anymore. So here goes again. Because why don't I have keyboard in here? What's wrong with this one? Oh, it has totally powered off. That is not good. That is not nice. So why is that happening anyway? I'm not doing anything out of the ordinary. I don't get that. Anyway, back in business. No, I have to take care of typing. Yes, and now for this, and of course here as well. There we are. and once again run it, and I hope it will divert this time so I can see difference in the waveform. But I have some doubts it will happen. If you want it to happen, it doesn't happen. But it does. It does. It definitely does happen. And it happens in such a short notice that you barely can see what happens. So that will have to be a conclusion afterwards. But I think well, something that has to happen is that this one has to run slower than this one. It's certainly diversion, this one. Alright. Last one. Alright, last part of this episode. I looked back in the recording of last segment, and I did not, unfortunately, notice a very big difference in the signal between the yellow and the blue one, the blue line. So I am now on pulse width. These are driven by pulses as well. You can count the pulses. So given time running short, I think it would be a very nice idea if I put 2 more probes and counted the pulses, because I have 2 more connections left on the scope. For now, let's also watch the code, because as you can see here, 2500 both motors, then both stop, then set distance 1400. Here, if contact 1 is made, then it turns around its axis, in the sense that if the axis is here, well, not the axis, it pivots around this point. Let's look further. Here as well, contact 2 is made, 1400 both, and again it pivots around this point, but the other way around. And then here, if both contacts are made at the same time, only a distance of 400. I might change that into 1400, but so far so good. With computers it has to happen really exactly at the same time for it being on the same time, and that rarely happens. So this is not something that will occur very frequently, but distance is the same, speed is the same. And they are, by now, they are all inside a sync data block, which is very important. So here also 100, 100 and both 128 speed, and here exactly the same. So although this is commented out, apart from that, there's no reason it should divert. Maybe it will solve with a new version, who knows. Right now I don't know. So let's for the last time run it. There it goes. And again, a very strong diversion. No touching, clearly a sonar signal, but a diversion. I will have to study these signals back as they have been recorded and see if maybe I can find a timing difference herein, but as I mentioned, I may also put I should also put probes here to count for pulses. Who knows what I will discover. Anyway, thank you for watching. If you like this video, please subscribe if you haven't done so to my channel. Also like this video. If you're on Twitter, please retweet and like. And if you're on Instagram, follow me and like. Please also donate to keep the videos coming your way. More information on my website, and on my website my other projects as well as lots of event pictures and videos. And this is going to be continued. Bye bye.